In this video, we're going to evaluate the double integral. So we are given this double integral right here. Whenever you evaluate double integrals, you want to evaluate the inner integral first. So when we have dy dx, we're going to find the integral of 35x4 to the 4th power, y to the 6th power with respect to y. Therefore, we're going to treat x's as constant, okay? So the first step to do is to rewrite this integral so that it's easier for you to read. So you separate the two integrals, y6 dy dx. Okay, now we evaluate the inside. So the integral of 35x4 to y to the 6 in respect to y, x's are treated as constants, so y to the 6 plus 1 will be y to the 7. So you have 35x4y to the 7 over this value plus 1, so over 7. And then dy would go away now, so you're left with 1 and 0, which are the boundaries, dx. Now you evaluate this part, you have 3 to the negative 2. 35, 7 goes into 35 5 times, so you're left with 5x4y7 with the boundaries 1 to 0 dx, okay? Now, next step is to plug in these boundaries. So 5x to the 4th, and y will be 1 to the 7th, minus 5x to the 4th, 5x to the 4th, y is 0, 7. Okay, dx. Now, anything to the, okay, let me rephrase. 0 to any power is 0. Anything times 0 is 0. So this is 0. Okay. You are left with 3, negative 2. 1 to the 7th power is 1. So you have 5x to the 4th power dx. Now, evaluate this integral right here. And since you only have x, you are going to evaluate in respect to x. So you have 3, negative 2, 5x4 dx, which is 5x5 over 5, boundaries 3 to negative 2, which you then have 5 and 5 cancels out. You have x5 to the 2 with 3 and negative 2 as boundaries. If you evaluate this, you have 3 to the 5th power minus negative 2 to the 5th power, which if you plug it into a calculator, 3 to the 5th power is 243 minus negative 2 to the 5th power is negative 32. So it will be 243, a negative times a negative is a positive 32, which plug that into a calculator, 243 plus 32, you have 275. So this is your answer.